All right, we're going to start with a bit of the real number system. We're going to be talking about the real number system in a bit more detail. All right, there are only 11 of you in this chat right now. So we're going to take advantage of the fact that there aren't that many of you in the lesson today. So if you feel like unmuting and saying something, I'm happy for you guys to unmute and say something and have a bit of a conversation with me, but it must be about the work, okay? So we're not going to like digress and then take a tangent and then come back. No, we're going to speak about the work. If you want to unmute and just answer a question, you're just going to unmute, answer the question, and then mute yourself again. Can I get a thumbs up if that's an agreement? Are we okay with that? I'm going to treat you guys as seniors and see if you guys can, if we can be responsible with our own mute and unmute. Yes, thank you. Thank you, Theo. Lovely princess. Well done. Thank you. Abu is always on the ball. Thank you very much. Thank you, Justin. Thank you, Lerato. Excellent, Nonka. All right. I just want to make sure, guys, remember, it's free-flowing. There's like 11 of us. There aren't that many of us. Let's have fun. Let's have a little bit of fun. All right. Let's start with the real number system, guys. If we look at these symbols, have we seen these symbols before? Who knows what these symbols mean? Anybody got any idea where these symbols come from and what they mean to us? Correct, Abu, yes, number systems. Correct, but be a little bit more specific. They represent rational numbers, not just, there we go. Good. So Abu says rational numbers and the sectors under them, good, but Theo says Z is equal to integers. All right, and that's exactly where we want to go with this, right? But I want us to start over here. I want us to start at the very beginning. Who knows what the N stands for? I'll give you a hint. The N also starts, that's it, princess. I was going to get there. You completely, well done. I didn't even finish my sentence and princess was already like, there we go. Yes, excellent. This is natural numbers, right? These are natural numbers and our natural numbers are our counting numbers. So we're looking at 1, 2, 3, 4, ... All right. What do we know about NO? What does this NO mean? Not zero. Good, princess. This means whole numbers. Okay, this means whole numbers. And our whole numbers are actually just our natural numbers plus 0. So whole numbers are just going to be all of them, all of the natural numbers that we have, just including 0. So 0, 1, 2, 3, 4, ... Okay, now, excuse me. Theo's already told us that Z stands for integers, right? We know that Z stands for integers. Now, if you look at the way that ma'am is actually explaining these numbers, I know that whole numbers are just going to be rational numbers or natural numbers plus one extra number. That means that my integers will have to be my natural numbers plus my whole numbers plus a little bit extra. So I know that my integers will include 0, 1, 2, 3, 4, ... like all of these would. But what kind of numbers do we then add to integers? What kind of numbers do we add on there? That's it, Abu, beautifully said. Good. We're going to add negative numbers. So -1, -2, beautiful. That's it. Good. Those are my integers. Excellent. Now, somebody's already told us that the Q over here stands for rational numbers. It stands for rational numbers. So if I have to then give a definition of rational numbers, I'm going to say that rational numbers are natural numbers plus whole numbers plus integers plus something a little extra. How do we write? Abu. Okay, Abu, here is my stylus. Here is my stylus. I think Abu's ready to teach. I don't know how else to put it because you're just on fire, my dude. Well done. Okay. No, I feel like you know it and you've got it. Okay. And I feel like I'm not going to teach you anything new because you're so good at this. All of you guys, you're just like crushing it. Beautiful stuff, guys. Okay, so we know that our rational numbers are going to be numbers that we can write as fractions. They're going to be numbers that we can write as fractions, like a half, or 6/7, or 3/5, right? Now I need to ask you, because I just said that rational numbers are natural numbers plus whole numbers plus integers, and they can be written as a fraction, how would I write -3 as a fraction? Because remember, rational numbers also include integers, and -3 is an integer. How do I then write -3 as a rational number? How would I be able to express it as a rational number? Yes, correct, Abu, 100%. It's going to be -3/1, because that doesn't change the value at all. But there, I've written it as a fraction. And that shows me that it is part of rational numbers. All right, okay. The only one that isn't part of this group that we have here is your irrational numbers. Okay, I just need some space. Irrational numbers, right? Your irrational numbers. What do we know about your irrational numbers? How do we describe our irrational numbers? No recurring decimals. I agree. There are no recurring decimals. There's no pattern to the decimals. Non-terminating decimals. Correct. Good. That's what I was looking for. I was looking for that example. All right. So the example of an irrational number is pi. Okay. I know that in primary school and in grade 8 sometimes we say that pi is equal to 3,14. But if we're being completely honest, do the decimals of pi come to an end? Correct, Theo. Okay, excellent. No, they don't. They don't come to an end. They go on forever and ever. It's actually 3,1415926 da 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 da, and it goes on forever, forever, forever. Okay, and that shows us that pi cannot be written as a fraction. Therefore, it is irrational. If I can't write it as a fraction, it's irrational. Like Princess is saying, if we take the square root of 2, if you punch the square root of 2 into your calculator, it's going to give you like many, 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 many decimals that don't have a pattern and that don't terminate. And, you know, it's messy, guys. It's a long number. There we go. It's like 1,414,213 dot dot dot, keeps going, keeps going, keeps going. So numbers like the root of 2, numbers like pi, all of these are irrational numbers. Okay, give me a thumbs up in the chat if you're okay with all of this, because we're about to go to the last one, and then we're going to get started on the actual meat of it. Ah, that's it, Theo. Good. We're going to move to real numbers. Beautiful. Thank you, thank you, thank you, Abu. Thank you, Princess and Theo and Nonka. Excellent stuff. Okay, now let's talk about real numbers. Real numbers are quite simple, guys. Your real numbers are going to be your natural numbers, your whole numbers, plus your integers, plus your rational numbers, plus your irrational numbers. All of these make up real numbers. Correct. Okay. And I will be a little bit careful with saying that all numbers that exist, because there are other numbers that exist outside of real numbers, and we're going to talk about that now. Okay. So real numbers is just every number except, who knows, except what? Who has an idea? I'm sure one of you has heard. Every single number on the number line except, Abu man, 100%. Right, the square root of a negative number. Like, for instance, the square root of -9. Okay, if you've got a calculator near you, Theo, that's a different story, and I'm happy to explain. I'm happy to explain why division by 0 doesn't work, but we'll talk about that in just a bit. All right, if you've got a calculator next to you, I want you guys to type in the square root of -9 and tell me what answer you get. That's it. We're going to get an error. Correct, Princess. It says maths error. Correct. Okay, but if we have to explain where this idea of the maths error actually comes from, let's take something like just the square root of 9. Okay, what is the square root of 9? Pop your answer in the chat for me. What is the square root of 9? That's it. Oh, Theo, that was super quick. Well done, Theo. Yes, that's it. The square root of 9 is 3, right? I also know that if I take 3 squared, what is 3 squared? What's the answer there? 3 squared is equal to what? Good. 3 squared is equal to 9. Right. Now, what happens if I say to you guys, I want -3 all squared? What is my answer there? What is -3 all squared? What are we thinking, peeps? Oh, it's not going to be -9. Be very careful, Theo. Be very careful. Ziketelo, you're correct. It's going to be 9. Let's explore that, Theo. Do you agree with me that 3 squared is the same as me writing 3 times 3? Agreed? Yeah, we're all good with that? 3 times 3. Excellent. And I know that there's a positive here and a positive here. A positive and a positive is going to give us a positive 9. Right. Now, if I then write -3 all squared, what this tells me is I want -3 multiplied by itself twice. -3 times -3. A negative and a negative will give me a what? What am I going to get? I'm going to get a positive. Correct. So my answer is going to be positive 9. Right. So that tells me that even if I square a negative number, my answer should still come out positive. That's why I'm never going to get the square root of a negative number that is real. Because when I square the +3, I get positive 9. And even when I square the -3, I still get positive 9. Okay, so my answer can never come out negative. Okay, give me a thumbs up. Are we okay with this idea? Okay. Beautiful, excellent. I'm glad, Theo. All right, I hope we're understanding what's happened here. Okay, even when we square the negative number, a negative times a negative is going to give us a positive. No worries, iPhone, please let us know what your name is so that we can rename you. Okay, beautiful stuff. All right, let's actually get into today's lesson because I feel like I've wasted enough time. All right, so we're going to be focusing. Hello, Omi, welcome. Okay, we're going to change your name just now. Teacher Christy, I don't know if you're still here. Are you able to change Omi's name for me? I think I may have lost Teacher Christy, but I'm going to change it for you. Don't stress. Rename to Omi. There we go. Welcome. All right. Oh, what have I done now? What have I done? Look at what I did. I opened a whole new thing called Omi. I'm sorry. I'm going to delete it after this. Welcome, Omi. All right, excellent. Oh, I think I may have changed the wrong person. I'm going to change this person back to iPhone. There's someone else named iPhone. iPhone, change, and then the second person. Okay, this is a little confusing, but I'm going to get to the crux of it in just a bit. All right, okay. So what we're going to be focusing on today is we are going to be focusing on integers. We're going to focus on integers, and we're going to focus on real numbers. Okay, those are the two things we're going to focus on. Right, now I want you guys to note that if we look at our natural numbers, and we look at our whole numbers, and we look at our integers, do you guys see how ma'am has described them as -5, -4, -3, -2, -1, 0, 1. Have I included -1,5? Yes or no? Has it been included in our description of integers? Yes or no? No, it hasn't. It hasn't been included. Right, we haven't included. Okay, they are integers. I'm going to tell you that, Abu, they are integers, just that our integers have to be very, very carefully laid out. Okay, our integers, correct, our integers need to be negative or positive whole numbers. They must be negative or positive whole numbers. All right. So we can only get -2, -1, 0, 1, 2, 3, like that, like that. Are we going to be able to include 2, 2? Can we include 2, 2 as an integer? No, we cannot. No, we cannot include it. We are only including whole numbers. And that's going to speak to what we're about to do next. Okay, we're going to be talking about how to express integers and real numbers on a number line. So I'm just going to check with you guys. Give me a thumbs up in the chat if you've already done this at school. Give me a thumbs down if you haven't, and this is the first time you're going to see what I'm about to tell you. Abu says thumbs up. Simoloho also thumbs up. All right. Omi is also thumbs up. Princess also thumbs up. Excellent. Okay. So there are quite a lot of thumbs up. So it means I'm not starting from scratch, which is great. Okay. We're going to start by talking about set builder notation. Okay. Set builder notation. Now, set builder notation helps us to express what we call, well, what we look at as the number system. Now, remember, guys, mathematics is a universal language. Okay, so what that actually tells me is, if I write out a mathematical equation and I give that mathematical equation to a Russian person who doesn't speak English, they should still be able to read the maths that I've written. Correct, Abu, that's it. Yes, they should be able to read what I've written and they should be able to solve it. So the idea of maths is that every single country speaks the same math language. So we're going to try our best to use as little numbers, or as little English as possible. And this is where set builder notation comes in. All right, I'm going to show you guys something very quickly. I'm going to write out what set builder notation needs to look like. Okay, and I want you guys to follow with me as I'm writing this. I'm going to say squiggly brackets. Now, these squiggly brackets means that we're going to write a set of numbers. This is how we start a set of numbers. All right, it's more than one number. That's one thing we know for sure. It must be more than one number. Sometimes it is one number, but at the moment, we're going to look at it as more than one number. And I'm going to say, there's a set of numbers. I don't know what these numbers are just yet. So I'm going to call these numbers X. I don't know what those numbers are. I'm going to call them X. But I do know that I want my X to be greater than or equal to 1. Okay. But I also want these numbers to be, these numbers X must be part of the integers number system. They must be part of the integers number system. Okay, now I want you guys to note here, what does the sign here at the bottom mean? Who knows what that sign there means? Okay, we know what this sign over here means, the one at the top, this one, that's greater than. Once I add a line at the bottom, that's it. Omi, well done. Yes, it means or equal to. Or, not and. Be very careful, guys. It's greater than or equal to, because it can't be and. Okay, or. Because if we say and, what you're actually saying is that this number, X, can be 1 and it can be 3 at the same time. That's a false statement. Okay, we need to use the word or equal to. Or equal to. All right. We need to make sure that we've got all of that put together. All right. Now, if I had to draw this on the number line, I know that X needs to be part of the integers. But where does X start? Which number does it start at? Look at this description over here. Where are we going to start? At which number? What do we think, guys? Where are we going to start? Correct, Omi, that's it. We're going to start at 1. Beautiful. We're going to start at 1. So we're going to go to 1 and we're going to put a dot. We're going to put a dot, right? Now, my crocodile mouth, as we call it, the crocodile mouth is open towards X, which means X needs to be bigger than 1. Which number is bigger than 1 on my number line? Give me an example of the number bigger than 1. 2, good. Anybody else? Any other number? Okay, we know that 2 is going to be one of them. 3, 4, 5, 7, 100, 16. It doesn't matter, right? 4, 5, 6. We're going to keep going. All right. Now, I want us to note what I've done here. I want you guys to note. Do you see how ma'am is not including the middle part? I haven't included the middle part. I've gone to each individual number and I've put a dot there. Why do I not include the middle part? Who knows? Bonus points if you can spot it. You can raise your hand, you can unmute, just let me know. Why have I not included those parts in the middle? Okay, Abu says, because it's greater than 1 and integer, I want you to be a little bit more specific for me. You are correct. No, Princess, think about it. If it's in between here, our smallest number is 1, right? If it's in between here, it's 1, 5. So I can put a dot there for 1, 5. Am I allowed to do that? Am I allowed to do that? Yes, Abu, correct. Good. Right. Listen to what Abu's saying, guys. Decimals are not classified as integers. They're not classified as integers. Right. So let's go back to the definition we had for integers. We said integers need to be negative or positive what? Whole numbers. Right. We said that they need to be negative or positive whole numbers. So we said that 2, 2 is not going to, it's not going to be an integer. 2, 2 is over there. So I can't include the space in between. I can't include it because as an integer, I can only include the whole numbers. Give me a thumbs up if you understand why I'm drawing the numbers on each of them. Why I'm drawing each of them individually. Are we okay with why I'm doing that? Excellent, good. Now, remember that this just says every number greater than 1. Theo even gave us the example of 8, 9, 10. So it doesn't actually stop at 6. It keeps going. So what I'm going to do is I'm going to draw an arrow like that to show that my integers keep going after 6. They keep going. 7, 8, 9, 10, 11, 12. They're going to keep going, keep going, keep going, keep going, all the way until infinity. Okay, infinity of whole numbers. All right, excellent. I want to give you guys a different one. Let me give you guys a different one, and I want you guys to draw it. Okay, grab a ruler and draw it for me, and then I want you to see if mine looks like yours. Okay, I'm going to say, I want the set of numbers. I don't know what the numbers are just yet, so I'm going to call them X. And these numbers, I want these numbers to sit in between -3 and 2. But I want them to be integers. I want them to be integers. All right, everybody's got 2 minutes. As soon as you're done drawing drawing the set on the number line, I want you to put your favorite emoji in the chat. All right, here's my favorite emoji. I love this emoji because maths is always lit, guys. Maths is always lit. Okay, so you guys have got 2 minutes. I'm just going to switch on the lights because I'm starting to sit in the dark, and then I will be with you guys. All right, pop your favorite emoji when you're ready, guys. Sure, you guys are super duper fast. I'm pretty sure that was less than a minute. That is definitely less than a minute. Okay. If some of you still need a little bit more time, I'm gonna wait a little. Okay, I'm gonna wait a little. Ah, nice one, Princess. Love that emoji, guys. Well done. Loving these. Okay, let's talk about this one. Okay, so I want us to note, guys, remember that that little sign over there at the bottom means or equal to. Okay, or equal to. Now, when we want to express or equal to on the number line, we need to draw a closed dot. And I'm going to explain what that means now. A closed dot. Okay. I'm going to draw a closed dot. So I'm going to start. Where am I going to start? Who's got an idea for me? Where are we going to start? Good, good, excellent. We're going to start at -3. But because -3 is included, which means my set must also include -3, I'm going to go to -3 and I'm going to draw a dot like that. And then I'm going to color it in. And that's what a closed dot looks like. This is a closed dot. Okay, closed dot. Right. How far are we going? How far are we going? Up until which number? Correct, correct. Up until 2. Beautiful. So I'm going to go to 2. Is 2 also included? Is it included? Yes, yes, it is. Right. Yes, it is. It's included. So am I going to draw a closed dot or not? Closed dot, yes or no? Closed dot. Good. We're going to draw a closed dot. Excellent. So I'm going to go to 2 and I'm going to draw a closed dot. Right. Now, remember, guys, x lies in between -3 and 2. So where else do I need to draw dots? Where else do I need to draw dots? Give me examples, guys. Where else do I need to draw a dot? I'm going to explain, Tyler. Don't even stress. I'm going to explain again. All right, I'll show you. I'll show you as we go. Good. Princess says at -2. Good. At all the other numbers. Give me another number, guys. Another number. 0. Good. Where else? Good, Princess. -1. And at 1. Beautiful. At 1. Can I draw a dot there? Am I allowed to draw a dot there? Yes or no? Princess says no. Abu says no. Zeketelo says no. I agree with you guys. Why? That number over there is actually -1,5. Why can I not draw that there? What do we know about -1,5? Correct. Sure. Abu, sir, my word. I love it. I love it. I love it. Good. Because we know that -1,5 is not an integer. Ketelo, beautifully said. Good. Decimals are not integers. They are not integers. Beautiful. Okay, let's look at a different example. Here's what we're going to do. I'm going to give you guys the example. Again, open squiggly brackets. All right. Oh, wait, I forgot to explain one more thing. Okay, here is the reason why we use x. Here is the exact reason why we use x. Because if we look at all of these numbers, my options for numbers is going to be -3, -2, -1, 0, 1, or 2. Do you see how I can't fit all of these numbers in there? I can't fit them all in there. So instead of having to write out every single number, imagine if ma'am had said from -3 to 22. Were we going to be able to fit all of these numbers in here? No way. So instead of having to write out all the numbers, we just use x. We just use x. All right. Bob notation, as in Bob the Builder. I like that one. Interesting. It's called set builder notation. Bob the Builder notation. Ah, shame, dude. Well done. All right. Let me give you another example. All right. And Kyla, I hope this will help us clear up how we know the difference. Okay, here's what I'm going to say. I'm going to open square brackets and I'm going to go, we're looking for some number x such that x needs to be less than 4, but we also want x to be an element of integers. Now, look at what we've done here. Have we included the equal to sign? Yes or no? Have we included the equal to sign over here? No, we haven't. We have not included it. We haven't included it. So this tells me that I cannot draw a closed dot. Okay, I cannot draw a closed dot. I need to draw an open dot at which number? An open dot at which number? Where are we drawing the open dot? Okay, Abu's guessing. I want everybody else to take a venture. Where are we going to draw this open dot? At? What do we think, guys? Okay, if you said 4, you are correct. If you said 4, you are correct. Okay, we're going to start at 4. Now, I have to put an open dot there because the equal to sign is not included. Okay. All right. So what this tells me is that every number needs to be included except 4. 4 is not included. Every number after 4 is included. So I want us to note what these signs actually look like. Okay, I want us to make this explicitly clear. I'm going to move over a little bit, just so we can get a bit of an understanding. Let's say, for instance, I said to you guys that x needs to be greater than 2. Now, this sign here in the middle, we call this a crocodile mouth. Do you see how the crocodile mouth opens towards x? Okay, if the crocodile mouth opens towards x, that means x needs to be the bigger number. Okay, this needs to be bigger. What number is bigger than 2? Give me an example of a number that's bigger than 2. Well, I don't know how to pronounce that number. That's correct. Thank you, Omi, for giving us a number I can pronounce. 13, 8, 15, 4. Correct. 77. Good. So if it opens up this way, we know that wherever 2 is, my x, or the way I draw my dots, needs to be the numbers bigger than 2. So if I do it the other way around, if I do this, x is then less than 2. My crocodile mouth opens towards 2, which means my numbers for x must be smaller than 2. They must be smaller than 2. Give me an example of a number smaller than 2. Good, Sketelo, good. 0, -7, -5, 1, excellent, good. -2, beautiful examples, guys, excellent. So let's go back and have a look at this example that ma'am's put here on the screen. Okay, if we look at this example over here, it says here that x needs to be what then 4? Less than or bigger than? Where does my crocodile mouth open towards? Okay, look at this example over here. Okay, which number is bigger? Or, sorry, x needs to be smaller than or greater than? Oh, I'm losing my words. X is smaller or bigger, guys? Abu says bigger. I want to hear from everyone else. What do we think of x? X needs to be smaller or bigger? Good, Skatolo. It needs to be smaller, correct. So we're going to go from 4. Where do I need to draw my next dot? At which number? Good. At 3, good, at 3. And what other number? Keep going, guys. What's the next number that we need to draw a dot at? 2, good. And then at 1, and then at 0, and then at -1, and then at -2, on and on and on and on. Now, because all the number, we don't know how far it ends, it goes on towards negative infinity, we're going to draw an arrow that looks like that. Okay, to show that these numbers are going to keep going on and on and on and on into infinity and beyond. Correct. Okay, give me a thumbs up. Is everybody okay with what I've done here? Are we all okay with how we express all of these numbers? Tabs ump, I'm with you there, tabs ump, well done. Thank you very much, Omi. Thank you very much, Nonka. Thank you, Princess. Excellent, guys, well done. Thank you, Sammy, I see you there, well done. All right. Okay, Tyler, please do let me know in the chat if I've explained well enough how to change this or how to draw an open dot versus a closed dot. Okay, just let me know in the chat. Yes, ma'am, I get you. I understand where you're coming from. All right, okay. Let's do a little bit of a change. Okay, I'm still going to be using set builder notation, but my notation is going to look a little different. Okay, I'm going to go squiggly brackets. I want some numbers in the set x, but I want my x to be greater than or equal to 0. But this time, I want x to be an element of real numbers. Now, if I want to express this, let's start over here. Am I going to draw an open or a closed dot? Open or closed dot? What do we think? Good, Omi, that's it. Closed dot, right. We're going to draw a closed dot. Who can tell us why? Why are we drawing a closed dot? Beautiful. I feel like, yeah, I feel like you are probably like the fastest typer I've ever met in my entire life, because you just move, my guy. Like before I've even finished asking the question, yeah, before I even finished answering the question or asking the question, like he's like, whoa, with it. I love it though. I love it. Good. We're going to put a closed dot. Where is my closed dot going? At which number? Which number is my closed dot going to? Good, correct, correct. My closed dot is going to sit at 0, right? But this time, okay, this time, look at what we're including. X is an element of real numbers. So I'm going to go to 0, and I'm going to draw a closed dot, right? Now, because my X is an element of real numbers, do I include this part? Like 0,8? Yes or no? Abu says yes. What do the rest of you guys say? Princess says no. What does everybody else think? Okay, if we're unsure, it's okay to be like, yo, ma'am, I don't know. It's fine. Okay, it's fine if we don't know. Okay, let's go back again and have a look. We said that real numbers are every number, every single number. Does that include 0,8? Does that include 0,8? Yes, it does. Does it include 2,2? Yes, it does. Does it include 3,5? Yes, it does. Which means that my real numbers include everything in between, everything in between. So instead of us now having to draw a dot and 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 a dot, we're not going to do that. For real numbers, we're just going to draw a line like that to show that we are including everything in between. We're including everything in between. All right, yes, all the numbers in between as well. Give me a thumbs up if what ma'am has just said makes perfect sense. Are we all with ma'am? You guys with me? Beautiful, 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 beautiful. Excellent. Okay, so we can also express real numbers in this way. Okay, I'm going to give you guys one to try yourselves. All right, here we're going to go. I'm going to go squiggly brackets x, some numbers x, we don't know what those numbers are, such that x is greater than -5, but x is less than -1, and x needs to be an element of real numbers. All right. Now, if there's any brave soul who would like to venture an answer by putting up their hand or unmuting, I'm happy to speak to you guys. But if you're shy and you don't want to speak yet, I'm happy for you guys to pop your answers in the chat. I just want to see if there's anybody, if I can hear at least one voice today, guys. Please, just one person's voice. One person. Anybody? Somebody? Anybody brave enough? Do it for your teammates, guys. Nobody? Okay, all right. Okay, I'm going to go with Abu's, that's okay. I'm going to go with Abu's suggestion here. Abu says we're going to go to -5, and he says we're going to put an open dot. Do we all agree? Do we all agree? Yes or no? Princess says yes. I'm happy with that. Okay, anybody else? Nonka also says yes, beautiful. So we're going to go to -5 and we're going to put an open dot. Correct, Princess, because it's not included. Beautiful. And then where are we going up to? Which number are we going to go to? Which number? Correct. Abu says -1. We're going to go to -1. And Abu says open dot. Do we agree? Yes or no? No worries, Tejo. Welcome. Okay. Do we agree? Yes, open dot, close dot. Okay, Princess says yes, open dot. I also agree because there's no equal to sign by my inequality over there. Okay, so I'm going to go to -1 and I'm going to put an open dot. Now, because it's real numbers, does it include everything in between here with real numbers? Yes, it does. Correct, it does. So what we're going to do is we're going to draw a straight line like that. Okay. And that's how we do that. That's excellent. All right, I'm going to give you guys one more to try on your own. Okay, I'm going to give everybody 2 minutes. Remember, once you're done, pop your favorite emoji in the chat. So I'm going to go. Some set of numbers x such that, let's start at -2, greater than or equal to, or less than or equal to x, and greater than 1. X is an element of real numbers. All right. I'm going to ask you guys to draw this one for me, and then I want you guys to put your favorite emoji in the chat so we can have a look. I'm glad you like this method, Abu. I find it long. I like interval notation more. Okay, we'll wait for everybody else. Okay. Princess, I love that emoji. Well done. All right, I think that's enough. I think I've got enough emojis. Okay, so let's have a look. Let's see what this should look like. And then you guys tell me in the chat if yours looks like mine. All right, so I'm going to go to -2. I'm going to go to -2, and I'm going to put a closed dot. Good. I'm going to put a closed dot because the equal to sign is there. And then I'm going to go to 1, and I'm going to put an open dot because there's no or equal to sign there. Now, I know that x needs to be in between these two numbers, and I know that it's a real number, so I don't have to put a dot, dot, dot. I can just join these with a line. All right. Connect the dots. Correct. Everybody got the same answer I did? I think most of us would have. Yes. Okay. Beautiful stuff. Larato's asking, are the classes every day or Monday and Wednesday? Only Monday and Wednesday, my sweetie. Omi, I'm so glad you get it. It's beautiful. Excellent work. All right, here's your next challenge. Okay, before we end off today's lesson, maths is nice again. Here's your next challenge. I'm going to give you the number line, and you're going to give me the set builder notation. All right, so I'm going to do this. All right, please give me the set builder notation for what I've put on the screen. All right, you've got 1 minute, pop your favorite emoji when you're done. Okay, it's okay, Teho. It's literally going to look the exact same. The only difference is the number set that we're using. X will be an element of something else. All right, we're going to take this one in the next minute. No worries, I'm here to help, my darling. Don't stress at all. Ah. It's not even an issue. Not even an issue. Okay, Theo's done. Let's see. Guys, I'm loving these emojis. I think, you know what, throughout the year, we need to kind of like experiment with different emojis. Like Justin's emoji, I love. Justin's emoji is on point. I like it. Okay. I don't know if it's a calculator or a screen. I'm trying to figure out what it is. It looks like money. Oh, it's a beeper. It's a beeper. Oh my goodness. When was the last time I saw a beeper? I love it though. I love it. I'm revealing my age, but yes, when I was growing up, people had beepers. Whew. All right, okay, let's get into this one. Remember, guys, it's set builder notation. So I'm going to start with curly brackets. I'm going to go curly brackets. I'm going to get some number x such that, colon, such that. Now, I already know that my x lies in between two numbers. So I know that x lies in between -5, and then there's an x, and then there's a 3. That's how far it goes, right? Now, if I want to know how to draw my signs here, I know that x needs to be greater. Do you see how x is greater than 5? Right, but -5 is not included. So my crocodile mouth must open towards x in that direction, right? But I do know that this thing ends at 3. It ends at 3, but x is smaller. So that means that my crocodile mouth must open towards 3. But do I need to add the equal to sign? Yes or no? Should I add the equal to sign? Abu says yes. Anybody else? What do we think? Should I add the equal to sign? Princess says yes. Omi says yes. Why do I need to add that? Why do I need to add the equal to sign? Okay. Oh, Mr. Khan, you are very, very good at this. Well done. Okay. It's because at 3, there is a closed dot. Good. But I want you guys to note how there's a dot, 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 dot. So that means that X must be an element of which number system are we working with here? That's it, correct. Element of Z, our integers. Okay, give me a thumbs up. Does your answer look like mine? Let me know. It's okay if it doesn't. It's okay if it doesn't. We're here to learn, guys. We are so here to learn. Beautiful, Timilucha. Well done, Princess. Oh, Hulani, well done. Amazing stuff. That's it, Omi. Well done. Ah, beautiful, Justin. Excellent stuff. You know what? I genuinely feel like we have started this year off on a high note. And guys, it's only up from here. You know, it's only up from here. That is our time for today, guys.